All right. Hello. How's it going? This is Terrence Fagan, and I want to go over something go over how to apply cross products to find the moment. So we're asked in a problem like this. You have three different forces all going in different directions, applied around a point here. That's O. So the first and foremost, we have to have the general equation. So the general equation to find the moment. So moment vector is equal to r vector cross the force vector. This is known as the general equation. So we're going to apply this general equation to one of these, and then you can apply it to other areas. So basically, what I want to do is I want to develop, have an r vector and a force vector, and then cross multiply them together. So first and foremost, what I'm going to do is I'm going to create what I'm going to call, make this green for this one. So I'm going to set this, and I'm going to connect this O with this up here, this point where this force in 3 is applied to this structure here, and we're going to call that, let's give this a B. So we're going to say that that's ROB vector. So over here, I'm going to change this now from green to black. So we have an R vector of OB. Now, here's where we can get into some things. So we already have our coordinate system. Notice how we have our X, Y, and our Z. So X is, you can put an I direction for X, a Y direction for J, a J direction for in our Y, and K is usually for the uh, Z direction. So in this case, ROB, we have an X direction. So if you follow this line here, that distance from here to here is B, because that's just the radius of this curvature around here. So that's in the X direction, and it's positive. So that's would go there. That's all you do. In the J direction, there is no in the J direction because it actually is in the XZ plane. This R OB, this vector, this R vector, OB is in the XY XZ plane. So there's no J. Now, there is a K component, and it's positive. All right. So oops. Positive, positive. So we're going to count from R. So we take from the x-axis all the way up, and it would be, at this point, it would be A plus the radius of this curvature should be A plus B. And that's how we would find our, our R vector. That's it. So you can do the same thing with if we put an ROC here and ROD here. You can see the same thing. You're going to get different, but you can trace that out. So that's the first step. Second step is trying to figure out the force vectors. So force of 3. If you notice this, there's nothing in the I direction. There is in the Y direction, and it's positive because Y is actually going into the board. So it's positive F3 magnitude, and there's nothing in the Z direction for this. So it would be positive F3J plus 0 in the K. So now we have our R vector. Let's circle this. So we have our R vector here, right? And we have our force vector here. Now we want to just use math and apply how we would take and cross multiply the two. How we do that in math is we would say that M vector is equal to, in this case, what I'm going to do is I'm going to have a unit vector up here as I, j, and k. That stands for the x direction, the j direction, and k direction. And then I'm going to put my r vector here. So I'm going to say b, nothing in the j, and then a plus b in the k direction. F3 only gets in the j direction. It doesn't have anything in the I or the k. So now what we want to do is we want to cross multiply them together. So in order to do that, there are many different ways to think about this, and many different strategies. But what I usually do is I can say, we can put a little bit of line here, and I can say I can cross out this one and this one first, and I can say I cross j gives me a k. So anything is I cross j will promote in the k, and it's going to be positive. So it's going to be b. It's this r value, and this is in the I direction multiplied by j. So we get b f3, and that's in the k direction. All right, that's all we do. Nothing more than that. So now what we do is we would say, so we would say anything from the I. Is there anything from the j direction to anything else? No, because 0 would cancel everything out. But there is something in the k direction. So we have a k cross a j. And with a k cross a j, you're going to get a negative I. So one way to remember this is if I have an I, j, and a k, if you're going crossing, it's positive. So with an I times a j, it's going to be positive. J times a k, it's going to be positive. A k times an I, it's going to be positive. Anything in reverse, so a j times an I is going to be negative. An I times a k is going to be negative. A k times a j is going to be negative. So in this case, we have a k times a j. It has a negative I, so it's going to get a negative a plus b times f3, and that is in the I direction. So again, you can put in the numbers, but let's expand this out a little bit. So we have this m, and I'm just going to rewrite it here. The m vector, we have b times f3 in the k minus a plus b. That's the r vector in the k direction times f3, and that's going to be I. This is how we would get the vector component, the vector of this moment. Now, if we wanted to find the magnitude, because that's what the problem's asking for, but not yet. Don't solve the magnitude yet, because it's asking for all the magnitudes left. So we got to do, we have a cross multiply of r times f2 and a different r times f1. So be very careful. But what you want to do is to find the magnitude. You would just say the magnitude of this is equal to the square root of the magnitude in the x direction squared plus the magnitude in the y direction squared plus the magnitude in the k direction, or z, squared, all square root. Basically, it's a Pythagorean theorem at that point. So that's how I would find the magnitude of all of the moments. So to wrap up, this showed you an application of this general equation where you cross multiplied the r vector cross the force vector to get the moment vector using mathematics. Hope you learned a lot, and I will see you soon.